In this problem, we have to find empirical and molecular formula of the compound carbon, hydrogen, oxygen. So first we have to calculate mass of carbon and hydrogen in 10.68 mg of compounds from CO2 and H2O. So mass of carbon is equal to mass of CO2, which is 16.01 mg, multiplied by the atomic mass of C in CO2, which is 12.001, divided by molar mass of CO2, which is 44.009. So the mass of carbon is 4.369 milligrams of carbon. Now find mass of hydrogen, which is equal to mass of water 4.37 milligram multiplied by the atomic weight of H mass of H in H2O, which is 2.016, divided by molar mass of H2O, which is 18.015, equal to, so the mass of hydrogen is 0.489 mg. Now we have to calculate percent percentage of mass of carbon and hydrogen. So for carbon it is mass of carbon 4.369 divided by the total mass of sample, which is 10.68, multiplied by 100, is equal to 40.908 percent. So percent of carbon is 40.908. Now find percentage of hydrogen in compound total sample, which is equal to 0.489 mass divided by total mass of sample, which is 10.68, multiplied by 100. So we get that percentage of hydrogen in sample is 4.579 percentage. Now to find percentage of oxygen, we will subtract out percentage of hydrogen and carbon from the 100 percentage, mean total percentage of sample. So the percentage of oxygen is equal to 54.513 percentage. Now the empirical formula is simplest whole number ratio of different types of atoms in compound. To find the empirical formula, we divide the percentage of each element by its molar mass to get the number of moles and then find simplest whole number ratio of the number of moles. So starting with the number of moles of carbon, so 40.908 gram divided by molar mass of carbon, which is 12.001. So number of moles of carbon are 3.4. Number of hydrogen number of moles of hydrogen is equal to 4.579 divided by molar mass of hydrogen, which is 1.008. So number of moles of hydrogen are 4.543 moles. Now the number of moles of oxygen is equal to mass 54.513 divided by molar mass, which is 16. So we have number of moles of oxygen are 3.4 moles. Now we have to convert them into simple whole number ratio of numbers. So number of carbon is equal to 3.4, 4.543 and 3.4. So we have to divide this number of moles by the smallest number of mole, which is 3.4. So we get it is equal to 0.331. Now we have to multiply or divide by 0.3 to get whole number. So we get that it 3, 4. We here we divide by 3.4. Here we divide by 0.33. So the empirical formula is empirical formula is C3H4O3. Now let that molecular formula is equal to C3X H4X and O3X. We have to find the molar mass of this formula, which will be equal to molar mass, which is equal to 12 multiplied by 3x plus 1.008 multiply 4x plus 16 multiplied by 3x. As we know that molar mass given of the sample is 176.1 gram, and the sum of these are also equal to 88x. So we have to solve for x, so we get that 176.1 divided by 88 is equal to 2. So x is here 2. So substitute. So the molecular formula we have is C6H8O6, and empirical formula is C3H4O3. So this is our final answer.